Okay.
All right, hopefully with less echo this time. All right.
Now our voices, you can hopefully hear us and our computer's off. So welcome to our second Kickstarter Live. Maybe by the third one, we won't have any screw-ups. So today we got a question. I'm Zee. This is Raphael. We're co-founders of Root. And today we're going to show you some demos of the hardware. We're going to show you demos using the interface for Root, and we have some special guest appearances from girls that you might have seen in our video, and we'll get to that in a little bit. We got a question from a backer that wanted to see more about the history of Root, so we figured we'll open up with just a brief kind of going through all the prototypes that we made. So, Raphael, why don't you introduce how Root started?
Yeah, so this right here is the first iteration of Root. I made this working with Professor Radhika Nagpal. This is her lab, actually, and made this actually many years ago. This would have been the summer of 2011. And so this one has, a lot of the same features. So it's got magnetic wheels, so it can stick on these whiteboard surfaces. But it also has there's some color sensors on the bottom. It can obviously drive with the magnetic wheels, batteries, microcontroller. But this didn't have kind of the wireless interface. It only erased. Obviously doesn't have like a nice case or anything like that. It did have some bumpers, and this was the first try at investigating magnetic climbing. And then ZL saw this and was like, "Hey, we can do something really cool and special with it." And we started to talk to teachers at that point and make this into a great learning tool.
So we spent about 4 months talking to teachers, figuring out what they really wanted in the classroom. We didn't really show them that. We were just exploring. And then we put all of our ideas together, and we hired an industrial designer to come up with, this is the first industrial design version of Root. We used Y Studios, if you're curious. And this was even though this has aged, this is about 3.5 years old, but you can see things like removable eraser, the marker hole. It's actually much, much, much bigger than where we landed, with Root. So this is the new Root, this is old Root. And from here we knew that we took this in front of teachers, and we knew we had something special, but we needed to make it smaller. So this is our engineering prototype to make Root smaller. Notice to make it smaller, we actually switched from a large marker to a small, and we exposed the wheels. But this was never actually supposed to go in front of people, just to be our demo test board. Then we went back to the bigger marker again briefly, and now you're seeing something that's a little bit more looking like what you've seen. This actually ended up being way too heavy for our purposes, so we needed to continually make it smaller and lighter. It's kind of hard to appreciate, but this thing is like a brick.
Then we ended up, so we went and made it a little bit smaller, cleaned it up a little bit. So this is kind of like iteration on the previous design. But what we found when we were doing testing was that people were having a little bit of trouble determining which side was the front of the robot, right? Like it's kind of Roomba-esque, but didn't have that much personality, and was could be a little bit tough when you were trying to program it, especially with these first learners. And so what we first did was we actually stuck on some googly eyes on the front here to try to give the robot a little bit more personality and show which side was the front, just when we were doing testing one day. And we found that that worked really quite well for bringing Root a little bit more to life, and also making it easier to program and follow. Then we kind of integrated that a little bit better into our design. We still had that dark crosshairs in the middle with the LEDs underneath, but now that the eyes were kind of integrated in.
And then, so the version that we're at right now is V8. This is our robot that we see on Kickstarter and that we're getting ready for production. Go through some of the features. There's light sensors underneath the eyes. The top of Root is also a whiteboard. And this is important because these are 4 programmable capacitive touch points. You can actually program Root to do different things depending on where you touch. There's an LED bar here that you can control the color. Root has the ability to lift and drop a marker. It has 2 bumpers, here and here. so you can bump the physical world. And
then yeah, like there's a bunch of stuff on the bottom too, so it might be hard to see. There's kind of the 1D scanning color sensor on the bottom here, so it's kind of like a one-dimensional camera. So this is how Root can see the things that you draw on the board. And then also, again, so there's some magnetic contacts for charging, and then also there's the eraser on the bottom that is actuated to help erase as well. And then 2 drive wheels, and then that's the robot.
Awesome.
So that's kind of the brief history. So, you know, we learned different things on each of these iterations. So this is kind of an important lesson in the engineering process for those of you out there who haven't done that. But I mean, that's a lot of what it is figuring out what's wrong, what we can improve, and then doing those changes to make it more reliable, more robust, a better user experience.
So the interface that we created with Root, I'll just load it.
Has also been through a lot of iterations.
Yeah,
but
we won't go through all of that.
Too much time to...
So I'll just load a basic program and connect to you. Okay. So we're connected to this robot. You can connect in the interface to multiple robots. When you select it, they light up. And then
I think you connect to one different.
You can explore programs in our app. So whenever you create a program, you could put it in the cloud, and then you can access other people's programs. Right now, I'm going to load a program called Line Follower. And then I want to show you the thing that's special about this is it's all based off of commands of if this, then that. So if these events, and we make all of the events that are accessible on the robot through this row right here, then perform these actions. And then we make all the actions. Sorry, there we go. Perfect.
Clear, maybe.
Then we make all the actions accessible here. So in a line following program, we have things like if the play button gets hit, then the robot drives forward and you set the wheel speeds. If any bumper gets hit, then the robot stops. If the robot sees black on a color sensor on the left, then the robot turns left. If it sees black on the color sensor on the right, then it turns right, and then so forth. And if it sees black in the center, the robot goes straight. So a program like this is just 7 lines of code. It could be shorter, but it also has priorities. These numbers that you see, 1, 2, 3, 4, 5, 6, 7, are the priorities of how this executes. So we're saying that if somebody hits the bumper, that's the highest priority in the stack, meaning that if it's in the middle of line following, the robot needs to stop. So what's special about Root is after you can, and this is a free-form environment where you can create all these relationships, create your own code, but you can explore different levels of operation. So we went from a graphical interface that required no reading to an interface that's more about computational fluency. And what we mean by that is now we have things like conditionals where you have to read, sensor values that you set. So before, sorry, there we go. Before, when we were picking numbers, it's just everything is moving via touch. Now you actually set values. You actually have access to what the robot sees, so you have sensor values. And then you can create these parallel stacks where you can have operations running in parallel. So you can create these complex relationships between variables and your rules in order to build programs. And then in level 3, you convert that into either JavaScript, Swift, or Python. So you're walking through all these stages of code development that essentially land you at a career-based language.
Thing here that didn't show up that program.
Yeah, so what we'll do is we'll show you some line following. Okay, so that's reset.
So yeah. You see? All right, so here, let me open up our example. So this was line follower. I will connect to the robot. Flash it up. Push play. And so you can actually see, if I hide this, you can actually see a little bit the highlighting of the blocks as they get called. And again, like Zee said, so there's different priorities for these. So if it were to see a line on the far left and right side of that sensor, which actually has 32 sensors, but we're segmenting it into 5 chunks to make it a little bit easier to program. But if it sees both of those, it's going to do the higher priority one. So in this case, if it were to hit an intersection or hit a line straight on, it would end up turning to the left instead of to the right. You can see kind of how this.
So Maya, why don't you erase a section
follows.
of that and draw a new?
Yeah, go ahead.
You're on top camera. So go erase a little small section
Here's
and draw a new line for it to follow.
Lead Root along a different path.
Well, oh, make it hard for us. Thank you.
What could go wrong?
I think it's not going to work, but who cares?
Well, I think it'll work. It just might hit the edge here.
Yeah.
And then you can see the bumper event is the most important. So the cool thing here is because it's just sending like wheel commands, you can actually have little places where it's going to jump. So it's like it's going to keep driving here because it didn't see a line. But there.
But you tap the bumper.
Yeah.
So notice that, you know, this is kind of what's nice about whiteboards is that they're a real-time environment, just like our app is a real-time environment. So it gets you to do fun, cool things. Like here, I'll show you an example of functions. So one sec, can you get me a robot?
Sure. Yeah. Just grab one off the board.
Is this okay?
Try 3, 3. There you go.
There we go.
So now he's connected to that robot.
So let's do a little exercise. We're going to do a function. We're going to make a little robot dance. So if I hit play, then I'm going to execute this purple boomerang.
So boomerangs are the way that in level 1 we reuse code. So when you throw a boomerang, it's going to do the boomerang event that he just dragged out there, and then it's going to come back if you and then run the next step.
So I'm going to come back and turn red. So what it's going to do is when I hit play, it's going to go to the boomerang, execute the turn command, and then go back and turn red. So
turn
and then turns red.
And turn red. There we go.
So now if I want to do a little dance, I can go turn right, turn, maybe we'll go.
So you can see each of these blocks, these action blocks that we have, has its own specific editor. That's all, again, it's all touch-based. There's no words you have to know. The biggest number you're going to see is 20. So.
And now every time I put one of these function blocks in there, it's going to repeat this function, and I'm going to have it change a different color every time it does this dance. So here we go. Stop. And we're going to hit play.
And again, so it's actually highlighting in there as well. And the cool thing you can do is we can actually pause it if we wanted to and step through the code one block at a time. So we found that's very helpful for kind of when you're debugging different types of programs as well.
So the other thing you can do with Boomerang, so now you're seeing this repeated function. You can also change these to if you wanted to have multiple functions. So now I can make this a blue boomerang and then say if blue boomerang, then we're going to play a song. So we're going to go C, G, A. And then maybe we'll do another blue boomerang here. Stop, play. So this is a unique way of combining sequences and functions. And then you can also then do some advanced maneuvers where you can put your you can call functions from other functions, or you can call a function upon itself. So in this example, I'm going to change this to purple. So now I'm going to execute these purple-like commands. The last one is going to be blue, and it's going to stay in this if blue sequence. So let's just see what that does. So it's going to do its dance. And then it's repeating in here. So you see it's stuck. And this is how we do loops in level 1. And if we want to break out of a loop, we could do something fun where if somebody hits the bumper, then we'll just make the robot glow orange. Oops. I said orange and I hit yellow.
Mhm.
But see, I put this as a priority 4. If I hit the bumper right now, it's not going to do anything. If I move this up above priority 3, it works, because it breaks it out of that loop. Now, what's interesting about this is I never actually had to recompile my code. I never had to send it to the robot. It's a real-time environment. The code is actually still running. So if I come back here, add a function or add a boomerang for going back to blue, if I tap that bumper again, guess what? It goes right back.
And just, similarly, you can even change what the notes are in real time. So it's all completely, real-time editing. And then with the priority system, you can do a lot of interesting kind of like logical ways of jumping around in your program.
So this is what we mean, that even though this is a graphical environment, it's a real coding environment that's going to get you to a certain capability. And that's when you're ready for level 2, which introduces computational fluency. And then level 3, which introduces text for all those people that joined late. So this is one interface that should last years, not just days for one experience. So I was thinking, for our next example, we would have Maya and Bella show off some of their skills at coding. Maybe we'll start with, who wants to go first? Bella.
We gotta
So
volunteer here. I'll hold this.
So with Bella, the program we're gonna do is we call Sidewalk, right? Do you need it?
Nope, you're good.
So with Sidewalk, we draw these squares around Root, and these squares are about the same of the size of the squares that you see in the interface when you select distance. And this is a very fun challenge that just starts with trying to go from here to a home at the end. Maybe, Bella, you can draw a home so we know where Root's supposed to go.
Go for it.
Awesome. So we're going to focus on just these first 3 blocks to understand direction. So the first block is just a distance block. And you can pick 20 steps, 0 steps, or back. Bella, why don't you hit play and see what the robot does? It went 20 steps up. So let's also try out what these 2 blocks are. So what happens when we go a turn block to the right and maybe a turn block to the left? Can you hit play and see what the robot does? So that turns to the left and that turns to the right. So why don't we work together to get Root to go from here to here? You think you can do that? Okay, it's all you. Maybe you can explain to us your program as you're doing it.
So what was the first step that you had, Bella?
Go straight.
Go straight? All right, so that'll get you 1 block forward. Awesome. What's the next step?
Turn that way.
Turn to the right?
Yeah.
Okay. And go forward. So now she's testing out her program. Went. It turned. Oh, it walked a little bit off the sidewalk there. Do you know where your problem was? Where you think you can fix it? There we go. And she's going to test it again. Forward, forward, turn. Ooh, that looks pretty
Close.
good. Looks good so far, right? What's the next step? So if the robot's right there, what would be the next thing you would have to tell Root if you want him to get home? Forward. Do you want to go forward, left, or right? So you're going to be in this block over there. I don't know if you want to point.
So you're going to be right here. You want to try stepping through?
Yeah, you can. You'd have to restart it.
Yeah. So let's try stepping your program through. That a lot of time helps.
You can push the nose. That's not the
So hit the step button.
So this is going to do one command at a time.
And then hit the step button again.
And because you can change the program while it's running, when you're stepping one step at a time, you can actually kind of slowly build up the sequence of your program.
Okay, so what do we want to do there? You want to turn which way?
So the program's paused right now.
Okay.
And whatever she drags at the end, it'll run that block when she steps or pushes play.
Let's see what it does.
Oh, you don't have a block there.
You want a little help? Okay, we'll do this program together. So right here, when the robot is like this, does it have to turn this way? Or does it have to turn this way?
On that one.
This way, okay. So which is the one that turns this way?
This.
That one, right? And then when the robot turns this way, and you want it to go up, or straight 20, there we go. So let's try out your program. Awesome job.
Well done, Bella.
Can I have you do one more challenge? Yeah? Okay. Can you, oh, maybe you should draw a light here. You want to draw, what color do you want to use? Purple. Okay.
So now the cool thing is, because again we have this cool whiteboard surface, you can actually edit that challenge in real time. So it's really easy to create the coding activities that you want to do, or change them on the fly, like Maya showed earlier with the line following example.
So now we're going to edit your code. So you went 420, 420, turned, 420, turn again, and 420. If you want to make it turn the light on over there, can you show me where you would add a light bulb in your code? Cool. All right. That was neat. You want to test it out?
No shiny purple.
Well, you have to turn it off if you want it to, or you could change it to a different color. You want to introduce something called a time? You want to make it turn into a different color here? I'll draw green. I'll give you a challenge. Maybe we have it turn purple for, I'll show you what this is, 2 seconds, and then you pick the time for there. What number do you want to put there? 3. Okay. So here we have timer functions. Can you add, that's the timer. So if you put that right next to the purple, it'll wait 2 seconds, right? Oh yeah, you have to change it to 2. And then where would you add green?
Next to the 2. I'm going like
Want to try it out?
Nice. It's going forward 20, forward 20. Then it's lighting up purple. It's waiting 2 seconds. Oh, and then
it turned green here. It's supposed to be green here.
So do you know what you might want to move if you wanted to change it?
oh no.
No?
I like it.
You like it?
that? Okay, well, we'll work on that. But what's cool about this is we're teaching sequencing, we're teaching debugging, we're teaching timing functions. So now kids have an appreciation for what does it mean to interrupt their code and when to do things. So the level of complexity in the sequencing actually is right aligned with kind of that part of your brain that you're trying to engage in computational thinking. And then what we wanted to do is also maybe do a demo. Maya, do you think you can make
another one of our...
All right. So we didn't really practice this.
You might recognize her from the main Kickstarter video, one of our stars.
So what are you going to do for us, Maya? Why don't you tell the camera?
What do you want to do? Do you want to race something? Do you want to?
Program that if you turn on the iPad, the robot will turn the way that the iPad's being turned. Yeah.
All right. Do you want to show? Do you have the code, or are you going to write it for us?
I'm gonna do it.
You're going to write it. Awesome. All right. I can move the table. So all right. So why don't you build up that program? So here we've got a blank slate that we're starting with. What is the first command? So she has, when you push play, she tells the robot to just go forward. And now when she tilts the iPad a little bit to the right, it's going to pivot around one wheel. She's adding another command that if you tilt it the other way, it's going to pivot around the other wheel. And so this actually, if she were to push play or connect to a robot and push play, you could have a very, very rudimentary version. I think you connected to a robot over here. I think it is. There you go. So now she's adding a third command if she tilts. Okay. If she tilts a little bit more. If she touches anywhere, it'll close out. Now she's adding a little bit more capability. So if she does a hard turn, it's going to turn around, spin in place. So and do the opposite for that side. So what she's doing here is actually adding the commands for essentially making a remote control, right? And you can kind of do this on the fly. And then now if she holds it straight, it's going to go straight. Awesome. Should we try it out?
Yeah.
All right. So now when she tilts the iPad a bunch there, it's going to turn around in place. When she tilts it a little bit, it sends a command to pivot around that one wheel. And so what she did in, what was that, like 30 seconds? Was essentially build a whole remote control.
Okay, so
There
why
we
don't you
go.
stop that, and what we'll do
We'll
is we're going to add a new rule that says if you see, why don't you take this, and then, because right now you can drive anywhere, but
If you see black.
I want to, if you see black on the color sense, well, why are you putting it up there?
Because if I put it down there, it won't work because it needs to be the main thing that will happen. Like, if it sees black, it will stop everything. And let's say go back 5 steps. No, forward. 5. Oops.
That's okay. So if it sees black in this priority, so as a priority 2, it's going to.
It will go back 6 steps.
Okay.
I'm going to change it to 5.
It doesn't have to be. There we go. So the problem right now is we don't see any black on the whiteboard. Can you draw us? No. Can you draw us
Something that we should avoid
something
crashing
we should
into?
avoid crashing into? Don't be mean. Oh, that's too easy. All right. Why don't we?
So she's got some blocks that she has to avoid when she's driving.
So why don't you drive and show me how you can drive around that then? So now you have things to avoid. Okay.
What's she gonna do if I do this?
No! Hey.
Stuck in a little cul-de-sac.
What? No.
Oh,
way.
it's
So
black.
it hit there, so you can see every time it goes backwards, right? The only command that's sending it backwards is the if you see black.
So maybe let's code in a different thing where if you see red, maybe the robot turns red.
Okay. As soon as I get around this.
All right. Can you hit stop? There we go. So let's add a new one in there. So
So
if you see red, that's even a higher priority.
this is
Then what do you want the robot to do?
actually won't be that high priority. It'll turn red.
Do you want to play a song or do anything else?
Then go forward. Actually, it will turn red.
Okay. Hit play.
So I added a couple red dots on the board there. Now if she drives over it,
Yeah, I'll drive over.
she's in the, I don't know, holiday spirit.
Holiday spirit.
Oh, now you have a red robot. Red robot, red robot.
So she can add another, edit her program and say like, now if it sees black, maybe the red light will turn off or something too.
All right.
And so you can.
So,
All right, yeah.
so
I don't know if we had any other questions.
let's see. Before we wrap up, does anybody there out there have any questions that we want us to answer? You can add them to the Q&A or add them to the chat window.
But yeah, we're happy to answer any questions about the robot. This is actually Radhika Nagpal's lab. So on this table, you can actually see these are small kilobots. So there's 1,000 of these little robots that go around on the surface and make cool little shapes. Just got other kind of cool robots around in here, but
Yeah.
for another day. So if you have any questions,
Yeah.
now's your chance. Otherwise, please
Back us on Kickstarter. That's what we need you to do. We really want to make it to the school.
Spread the word.
Because we really want Root to be something that can make an impact in the world. And in order to do that, we need to reach our funding goals so we can get into tooling. Michael Konapa, I don't see the question, but.
Yeah.
All right, well, we're going to do another one of these Kickstarter lives. So if you have other questions, you can shoot us an email, or you can keep an eye on our Kickstarter for when we run the next live coverage. But for the Root team, to the backers out there, oh yeah, come on back. Take care, guys.
Spread the word. Thank you.
Spread the word.
Kool-Aid Man.